Good morning. My name is Bharat, and I'm the CTO for Raft. Today, me and my teammates will show what the progress Raft has made over the last 30 days. We'll give a high overview of some of the architectural decisions we're making and why we're making those architectural decisions. So we'll dig right in. I'll start with sharing our high-level architecture diagram, and I'll go into details of why we're choosing some of the architectures that we're choosing. So the biggest problem that we are trying to resolve as part of Data Fabric is provide a way to combine multiple disparate data sets into a single control plane. And that is a system or an architecture that doesn't exist today between Space Force or even Air Force. So on the left here, we're depicting the disparate data sets. These data sets could be in any format. UDL is in Kafka, but BDP could be in RDBMS. So these could be any formats of data sets that exist within the enterprise. Now, there isn't a single way to access these data sets and combine data from them in a single control plane. And that's what we're really fixing with Data Fabric as part of this square. So I'll go into details of why we're choosing each and every technology. First and foremost, this entire thing is built on the government-owned baseline. So we are building on top of Platform One Big Bang. And most of the solutions that we're using as part of this stack are open source. So we're not tying ourselves to any long-term vendor licenses. So the first thing we are building is a federated data abstraction API. And why we're building that is every time new data comes into UDL or any other data source, there needs to be time and resources spent to get that data converted to the format that UDL expects. We are building a data abstraction API, so it doesn't matter which format the data is in, we can consume that data in that same format. So that drastically reduces the time and energy spent in consuming new data. So, and that's part of the, as covered in the presentation, part of the use case that we're also covering for SDA use case, being able to ingest the commercial data without having to spend additional energy to get that data converted into the format that is expected. So, and then over on the left, on the Kafka side, so we include fast streaming. So we can ingest fast streaming data from raw sensors or as well as from other systems within the Space Force or Air Force. Why that is important and how Data Fabric is doing that differently is right now there doesn't exist a way to do data security, ICAM, at the data streaming level. So as the data is streaming in, there isn't a way to do a fine-grained access control of data. That is possible only for data at rest. That is not possible today for data that is in motion. So that is what we're doing here, so that when Bharat runs the same query on data in motion versus John Doe, who runs the same query on data in motion, we get different results based on our policies and access controls. Now, as the data is being streamed in, we want to be able to analyze that data in real time and not take days or weeks or months, but analyze that data in real time. And that's where Apache Droid comes in. We're analyzing that data in a streaming way. And then we need a way to visualize the data set as well. And that's where we're using the Apache superset so that non-technical users can slice, dice, and curate the data using a user interface. And then finally, we are using something called Trino, which is an open source product that came out of Facebook. Trino allows us to provide a single control plane using SQL. We can connect to any of these data sources. So there isn't a solution out there that does that other than Trino. So whether your data is in S3, whether your data is in REST, whether it's in UDL, we can connect to it using simple SQL. And then any operational users, and operational users could be operators, could be data scientists, could be stakeholders, as long as those operators know SQL or can visualize the data using superset, they can combine all the data from these blue boxes over here. And then finally, we want to be able to replicate the data across geographical locations. So we discussed that at Dahlgren. Again, the problem of being able to replicate data between Dahlgren and Vandenberg, That problem we are solving by, as the data comes in a raw streaming way to a central data fabric, in real time, that data is also replicated to a different geographical location where data fabric is deployed. And we're calling that a data fabric edge. So these are our high level architecture diagrams. And the way we have built the solution is we are able to deploy this entire thing using a single line of code that takes parameters or flags for each one of these boxes. So anybody can spin up the entire solution using a single line of code. And if they don't want a specific piece, they can just remove that piece. The last thing I'll cover here is a solution that we're using from open source called Data Hub. That's, again, a problem that we discovered as part of the CEO data sprint, and we've seen as part of the MVP use case as well. There doesn't exist a way to be able to visualize the data lineage across the data. So as the data comes in from a raw streaming source, it gets transformed to be able to make that data useful. But there isn't a way at the enterprise level to visualize that transformation of data. How did that data come in from the raw streaming data? How did it get transformed? And who's using that data? So that solution doesn't exist, and we'll show a demo of what we built to make that possible. So now I'll pass it over to my teammates, John and Karthik, to show how we are doing fine-grained access control based on user groups, user policies, and user attributes for fast streaming data. So I'll pass it over to John and Karthik.